Hi guys, welcome to the video on 3C. We are dealing with inequality still, but now we are adding absolute value, more absolute value solving situations as well. So we have some equations down here. We're going to start with equations and then we'll move into the inequalities. You can see right there the word inequality. That's coming probably on the next video. So these will be pretty straightforward. These are equations, and we are going to get the absolute value, the grouping symbol by itself. That's the first thing we're going to do. And then we are going to look at the situation, and we are going to ask ourselves, what equations do we have to set up to get all of the solutions for this possible absolute value statement? So let's just do some examples. We need to get the absolute value symbol by himself. He's not by himself. I'm going to add 3 to both sides. Now I've got the absolute value of x equaling 2. That's all well and good. Now I've got to figure out what values could be possible for x to be, for its absolute value to be a positive 2. Well, we know if x is positive 2, his absolute value is positive 2, but he could also be negative 2 inside that absolute value symbol. So when he comes out, he would come out as a positive 2. So the solution set, the set of all numbers that make this equation true, are negative 2 and positive 2. Let's look at example B. Again, I need this absolute value all by himself. He's got a bunch of stuff attached, both by addition and by multiplication. So I'm going to clean this up, subtract 14 from both sides, and I end up with minus 3, absolute value of x, equaling minus 12. Don't forget this negative sign. He goes with the 3, this guy right here. That's where he came from. Okay, well, we're almost there, except for the absolute value of x is still not alone. He's got a coefficient of negative 3. Go ahead and divide both sides by negative 3. That leaves us with the absolute value of x equaling a positive 4. So once again, I ask myself, like I did in example number A, what could the possible values inside be to make the absolute value a positive 4? And once again, we're thinking, well, it could be a positive 4, but it could also, x could also equal a negative 4. So my solution set is negative 4 and positive 4. So this is all great, but let's complicate our equations a little bit here. So in example C, the absolute value sign is by himself on his side of the equal sign. That's good. We don't have to do anything there. So we ask ourselves, what this expression, x minus 2, if it ended up being a positive 3 when we solved it, then our absolute value would be positive 3. But also, if this guy ended up being a negative 3, when we took him out of the absolute value sign, it would turn him positive. So we are actually going to have to work 2 equations to find our solution set here. So we're going to add 2 to both sides, and we're getting x is equal to 5. Add 2 to both sides, and x equals negative 1. So if this looks a little strange, ask yourself, if I plugged 5 back in, right here, 5 minus 2, does that equal the absolute value of 5 minus 2, does that equal positive 3? Well, sure it does. But what about the negative 1? If I plug negative 1 in here, does the absolute value of that also equal positive 3? Yeah, it does. So that's why there are 2 answers for these equations. There are 2 different values that x could be that would give us a true statement. So our solution set, once again, we write this little funky looking squiggly thing. We write the smallest number first, the larger number second, and this says all possible answers for this problem are negative 1 and positive 5. You guys work D on your own. We're going to work it in class. I want to come back and throw throw just another example out here for you. Let's see, which one do I want to do? I'll come down here and do F, and then we'll see how much longer the video goes. So I've got to isolate the absolute value. I'm going to subtract 3 from both sides. All nice. This minus sign comes down as the ghostly -1 outside the absolute value. And we're all good, except we got to get rid of this -1. So I'm going to divide both sides through, the whole thing, by -1, both sides. Now finally, I have my absolute value positive and alone, and I've got negative, oh, that's not -2, it's -1. So I have -1 on this side of the equal sign. All right, let me get some more room going here. So now I ask myself, okay, I've got to take what's inside here, take him out, and I have to find out where is this value equal. This is a -1, -1, +1. So that wasn't going to make any sense. Where is the point where negative x minus 7 is equal to 1? Or it could end up being equal to -1, because when we take it out of the absolute value sign, it will turn it back positive again. So I'm going to add 7 to both sides, and x can be 8. I'm going to add 7 to both sides, and I can get x equal +6. If you want to prove your answer, go plug it back in, the original equation. Go up here, plug in 8 and 6, and see if you get a true statement. So our solution set, again, we'll write the 6 first, and we'll write the 8 coming second. So you guys are going to do number E on your own. This video is long enough. You've got 2, D and E to do on your own, and I'll see you back here with the next section. Bye-bye.